Please open your learning workbooks to page 136. Let's solve some Alex problems. We're actually going to start at the bottom of page 136 with the following. Suppose that the functions f and g are defined as follows. Suppose f of x is equal to x over the difference x minus 9. And g of x is equal to 5 over the sum x plus 4. Find f over g, then give its domain using an interval or union of intervals. Simplify your answers. Hint: the only way that a fraction can be equal to 0 is if its numerator is equal to 0. Okay, let's go ahead and solve this problem. Find f over g and its domain. And we want the domain as an interval or a union of intervals. All right, so the first thing that we might notice about this problem is that it does not ask us to find f over g of x. It just asks us to find f over g. Well, f is a function of x, and g is also a function of x. So when we combine them together, the result will be a function of x. Writing f over g is the same as writing f over g of x. Using our previously agreed upon definitions, this is f of x divided by g of x. All right, let's see now if we can substitute. F of x is equal to this fraction, so we have x over x subtract 9. G of x is equal to this fraction, 5 over the sum x plus 4. Notice that this is the first line of algebra where our function names, f and g, are no longer in our problem. Therefore, we must stop and determine our domain at this time. We'll go through the 4 steps just as we have in other problems of this type. But we'll do so in a slightly accelerated fashion. By looking at the problem, we see that there are no even index radicals or logarithms, which means the only steps we need to apply are steps 1 and 4. Step 1 says, start with all real numbers. And then step 4 says, anything that would result in an undefined situation would affect our domain. Well, in our previous video, we learned that 0 is acceptable up here, but not here, or here, or here. 0 is okay in this position, but not any of the other 3. So what that tells me is, I start with all real numbers, and then I adjust that based on the following statements. X minus 9 is not allowed to be 0. 5 is not allowed to be 0. And x plus 4 is not allowed to be 0. Let's solve each one of these one at a time. X minus 9 is not equal to 0. Add 9 on both sides, we get x is not equal to 9. 5 is not equal to 0 is a true statement, but it doesn't tell us anything about x, and therefore it doesn't contribute to our domain. X plus 4 is not allowed to be 0. By subtracting 4 on both sides, we get x is not allowed to be negative 4. Therefore, our domain consists of all real numbers except for 9 and negative 4. How shall we write that? We want an interval. Well, if this number line represents all real numbers in the world, and then we go back and we say to ourselves, but we wish to remove negative 4 as well as 9, well then that would put a hole or a missing value at those 2 locations. And it would break our single interval up into 3 pieces. The values from negative infinity all the way to negative 4, the values from -4 to +9, and the values from 9 to infinity. Let's write that as a final interval. We would have parenthesis, -∞, comma, -4, close parenthesis. That's this first union. That's this first interval, excuse me. Union, -4, comma, 9. That's this second interval. Union, parentheses, 9, comma, infinity. That's this third piece here. Okay, so now that we have found our domain, we can go back and finish simplifying our problem. Now, some textbooks say that this is an acceptable final answer. Others regard this as a complex rational expression that must be simplified by following the division rule we discussed previously for fractions. Keep, change, flip. If we were to keep, change, flip with this fraction, what would the result be? We would have x over x subtract 9 times x plus 4 over 5. Putting this together, we would have x times x plus 4, note the use of parentheses around the x plus 4, over 5 times x minus 9. This would be your answer in factored form. Another possible form would be to distribute the x and the 5 to get the value x squared plus 4x for the numerator and 5x minus 45 for the denominator. 3 possible final answer forms. On my exams, I would accept any of the 3. All right, let's move on to another problem. Let's do the problem that is in the middle. Suppose that the functions g and f are defined as follows. G of x is equal to x plus 4. F of x is equal to the binomial x minus 2 times the binomial x minus 3. Find f plus g of x. And f dot g of x. Then give their domains as an interval. Okay, let's solve this problem. Let's start with f plus g of x. That would be f of x and g of x added together. F of x is the x minus 2 times the x minus 3. G of x is the x plus 4. Because this problem asks us to determine domain, we notice that the letters f and g are absent from this line, and it's the first line of algebra that does not include them. Therefore, this is the moment where we must stop and determine our domain. The 4 steps of domain are: start with all real numbers, even radicands greater than or equal to 0, there are none, log arguments greater than 0, there are none, denominators not equal to 0, there are none. Therefore, the domain is all real numbers, which as an interval would be written like this. Now continue to simplify. Let's FOIL the 2 binomials. X squared minus 3x minus 2x plus 6. And then to that we will add x plus 4. Let's combine like terms. X squared minus 3x minus 2x plus x makes minus 4x, plus 6 plus 4 makes plus 10. This is our final answer. And there were 2 questions, 2 answers. Find f plus g of x and its domain as an interval. We did both of those things. This is f plus g of x in its simplified form. This is the interval representing its domain. Okay, let's now turn our attention to f dot g of x. We have f of x and g of x being multiplied. Again, we replace. F of x is the x minus 2 times the x minus 3. G of x is the x plus 4. Notice that we're replacing g of x with something new, and g of x is a multiplier. Therefore, it must be included in parentheses. This is the first line of algebra where our function names have been removed. So we use this line of algebra to determine the domain of our function. As before, there are no even index radicals or logarithms or denominators, so the domain is negative infinity to positive infinity. Now continue on with the simplifying step. We will once again FOIL this part of the problem. Notice that this is the same part that we did a moment ago, and we're going to get the same result, which was x squared minus 3x minus 2x plus 6. However, this entire piece now must be multiplied by this x plus 4. We will, of course, simplify inside first. X squared minus 5x plus 6 times the x plus 4. We must now multiply one more time. However, we cannot use the FOIL method. The FOIL method is for binomial times binomial. This is a binomial times a trinomial. But the idea is very similar. Each term from the trinomial must be multiplied by each term of the binomial. So for example, the x squared and the minus 5x and the add 6 will all be multiplied by this x. And similarly by this 4, creating a total of 6 terms that we must combine. Okay, let's do the x first. When x is distributed to each one of these 3 terms, the exponent of x goes up by 1. Instead of x squared, we have x cubed. Instead of minus 5x, we have minus 5x squared. And instead of plus 6, we have plus 6x. Now distribute the 4. Plus 4x squared minus 20x plus 24. Now combine your like terms. The x squared terms, for example, and the x terms. Our final result would be x cubed minus 5 plus 4 is minus 1, or simply minus x squared, plus 6 minus 20 is minus 14x, plus 24. As before, there are 2 answers because there were 2 questions. What is the function f dot g of x? This is the answer. And its domain as an interval. This is the answer.